Hi and good evening. My name is Ahmad Zairin Ali bin Yaakob. My metric number is DE220103, and today we will be presenting on our chosen topic, which is hard disk drive. So we are from Group 10, consisting of students from Section 3 and 4. Okay, next, these are our group members. I am Zairin, and we have Irfan Jam Sharif as our second member, Iqbal Fadzil as our third member, Lukman Arifin as our fourth member, and last but not least, Ashraf Zubahri as our fifth member. So, moving on to our table of literature review. So, this is our table of literature review, and from this table, we have 10 reviews. However, we can summarize them into 6 topics related to HDDs. So our 6 topics include improvement of HDD characteristics, advanced HDD recording techniques, fourth generation in HDDs, data storage and retrieval in HDDs, comparison between HDD and SSD, and material science in HDD. So for the first topic, improvement of HDD characteristics. And the document highlights the advancement in magnetic field technology and its impact on improving the characteristics of hard disk drive or HDDs. And over the years, technological innovations have significantly enhanced the performance, capacity, and reliability of HDDs. So, these improvements include the development of better data storage techniques that allow for more efficient and dense data recording, advancement in read or write speeds, which result in faster data access and retrieval, and increased storage density that enables larger amount of data to be stored in the same physical space. Such advancements have made HDDs more robust and effective in meeting the growing demands for data storage in various applications. Okay, moving on to our second topic, advanced HDD recording techniques. So, the document explores advanced HDD recording techniques developed to meet the growing demand for higher storage capacities by significantly increasing the areal density of HDDs. And among these techniques are bit pattern magnetic recording (BPMR), heat assisted magnetic recording (HMR), and microwave assisted magnetic recording (MAMR). So, bit pattern magnetic recording arranges magnetic material into small isolated regions to reduce interference and increase density. And then, heat assisted magnetic recording uses localized heating to reduce the coercivity of the disk material, allowing for denser data recording. And lastly, microwave assisted magnetic recording employs microwaves to assist in the magnetic recording process, enabling precise and efficient data writing. So these innovative methods enable the storage of more data within the same physical space, enhancing the overall capacity and performance of HDDs. So I think that that's all from me. Thank you.
Good afternoon and hi. My name is Muhammad Iqbal bin Fazil and my metric number is DE220206. And today I will present a literature review for point 2 and for point 4. Point 3 and point 4. So point 3 is fourth generation in HDDs and fourth point is data storage and retrieval in HDDs. So we go through to this point. So for the fourth generation in HDDs, it's focused on analysis of Hellback magnetic circuit and their impact on fourth generation in HDD voice coil motors. So in details, Hellback magnetic circuit are used to increase the force generated in the voice coil motors of HDDs. So this allow for more efficient movement of the read and write head, which is critical for faster data access and retrieval. So next for point number 4 is data storage and retrieval in HDDs. So this this review is about examination of the susceptibility of magnetic hard disk drive to external DC magnetic field and the mechanism of data storage and retrieval. So In this review, we discuss about how this drive store and retrieve data using movable read and write heads, and how external magnetic influence can disrupt this process. So many of information that have in this journal, so we can refer to that review, so we can conduct a good investigation. So that's all for me. Thank you.
Hi, my name is Muhammad Ashraf. So for this part, I will do comparison study between the HDD and SSD. Solid state drive SSD and hard disk drive HDD are data storage device. But then the difference between them is SSD store data in flash memory, which is temporary, while we study the HDD will store the data in magnetic disk permanently. Hence, we do the study on how HDD work and compare it with the SDD device. Okay, we also study into material science in HDD. So we take into account the challenge and also issue that related to high density magnetic recording media, and we focus on improving the memory storage capacity of hard disk drive that involve the several advanced technologies and also technique we must focus on. So at first we focus on the increasing data density. We also optimizing the storage architecture, and we learn to enhance the overall performance for HDD device.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Sharif. My matric number is DE220201. So my part in our project is expected result by understanding the magnetic principle for data storage and retrieval in HDDs, including the role of magnetization and magnetic domains. We can elucidate how data is efficiently encoded and decoded on the disk surface. However, despite completing our project, we encountered an issue where the HDDs did not function as expected because the actuator arm was broken. The actuator arm, which is responsible for moving the read or write head to the correct position on the disk, is crucial for accessing data. Its failure prevents the HDD from reading or writing data, highlighting the importance of robust mechanical components in the overall functionality of HDDs. This setback emphasized the need for rigorous testing and quality assurance of all hardware components to ensure the successful operation of HDDs. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lukmanul Hakim bin Muhammad Arifin. My number metric is DE220205. So I'm from Group 10, Section 4. So right now I will show you the demonstration of our group project, which is about the magnetostatic in hard disk drive. So first of all, hard disk that we have used for this experiment is we only reuse the old hard disk from the old computer, so it will not harm and anything. So we will discuss about how it works. So this is our HDD. As you can see, it's external HDD. We can connect it with the laptop or the PC. So a bit introduction of the HDD. Okay, as we know, magnetostatic is the study of magnetic field in the system where the current are steady. So meaning that they are not changing with the time. Magnetic field are created by moving electric charges or magnetic dipole. For the magnetic flux, it's measure the quantity of magnetism considering both strength and also extent of the magnetic field. So, within the material, we have the magnetic domain in a HDD, which is the region where the magnetic moment are aligned in the same direction. So as we all know that HDD today are widely used in the computer or in the data center. So after this, I will break through around all the component that in HDD with the function. So we will go next. So right now I will break through for all the component in this HDD and also the function of all these component. After that, I will demonstration and put the power source in this to see how it's work. Okay, so first of all, as we can see here, this one is the disk or the platter, which is this platter is contained by a disk where data is actually stored and coated with a magnetic material that can store data in the form of the tiny magnetic domain. So for this one, which is the one that can be rotating, that will be rotating and move the disk. Okay, this name is actually spindle. Spindle is actually used to hold the platter in a place and spin them at the constant speed. It's responsible to rotating the platters. So next, as you can see here, we can move this. At the point T is actually the read or write head. Read or write head is actually function to the platter, which is it has two head, one for each head, one for each side. So it will read the data from the write data to the platters. So next, which is the one that makes sure the read or write head is moving is actually an actuator arm. So in actuator arm, its work to move the read or write head across the platter surface. It's also the position of the head over the correct track to read or write the data. So it's responsible to move the read-write head to make sure we can store data or save the data. So next, here, as you can see that I have been point here, this is actually an actuator. In actuator, a voice coil motor or a VCM is actually function to control the movement of the actuator arm. It uses an electromagnetic coil to move the arm and position the read-write head accurately. So for the last one is here. As you can see here, this is actually actuator axis. So in the actuator axis, it actually serves as a pivot point around which the actuator arm rotates. It also acts as the central point around the actuator arm. The precision is critical for accurately the read or write head. So the function is actually to make sure the actuator arm rotates in a correct way to read the data or store the data. I will explain a little bit about the data storage using the magnetostatic. So actually, how does data storage is actually work using magnetostatic? Okay, when we writing the data, the write head is actually generate a magnetic field that align with the magnetic domain. So in the platter material, it will represent the binary data, which is 1 or 0. So when reading the data, the read head detect the magnetic field from this aligned domain and convert the change in the magnetic field back into the binary data. Right now, I will present about how this hard disk drive actually works. So when the drive is actually on powered off, the head are actually resting on the ramp, on this ramp. As you can see here, this is the ramp that holding the head or right or read head. So the arm will swing off so that the head are preserved. They are not touching the disc or anything. If I want to write or I want to read, if I want to record a picture or I want to bring out a picture file, this arm, this actuator arm will swing out over the disc, and the heads are actually flying over the track, as we call them. So it goes to a very specific radius, and actually the drive will be given an address to go. So that was the radius. So next, in this head, there are a transducer. The transducer are on the head sense for that domain. So the direction of the magnetism and whether it is a 1 or 0 in a bit, the head take all of those bits and transmit that electrically up into the channel. So after the write or read head have been read the data on a bit, it will transmit the data on here, which is the bit will transmit that electrically up into the channel. So next, it will reconstruct back into a data from that we recognize as an image. So here, the actuator. So in this actuator, there is actually a component which is a voice coil motor that actually drive the actuator arm. As you can see here, this is the actuator arm. Its function to move the actuator arm. So if the voice coil motor or VCM fails or does not receive the power, the actuator arm will remain stationary even the spindle spins. This could be because of the VCM coil could have burned out because of power surge or prolonged operation. So right now I will power on the prototype of our group hard disk drive, and I will power it on with my laptop. And as you can see here, as you can see here, it's actually, the disc actually moving constantly, and the spindle can hold the disc correctly. But when we connect with the computer, the data will not be written. So this is because this actuator arm is cannot move to read the binary data on the magnetic domain. So here, as you can see here, it should be like this. It will be the right or read head will read the data, and it will reconstruct here and transmit in electrically to the computer. So I think that's all from our group. Thank you.